This video is for section 1.3 on graphing part 2. Okay, so in the last video we learned about graphing equations using the point plotting method and the x and y intercept. And so today we want to look at understanding parent functions, and then we're going to use those to help us graph as well. So these are called parent functions, and anything that looks like them is always going to have the same resemblance. And so, for example, if we wanted to look at this line, we call it the constant line. And notice it's a horizontal line. And so what we're interested in doing is finding the x-intercepts. And so here, the line does not cross the x-axis, so there's no x-intercept. The y-intercept is going to be at this point right here. And so this point is just 0 and some number c. So we can say that the y-intercept is at y equals c. And the zeros, remember that they are the same as the x-intercepts. And so in this case, we have no x-intercept, so we're going to have no zeros. Okay, so the description of the line or the graph here is a horizontal line passing through the point C, in this case, C. So the next graph is called the identity function, but we also call it the linear function. Okay, so the equation is f of x is equal to x. And so the x-intercept here is at 0, 0. And the y-intercept is also at 0. So the 0 is going to be x equals 0. And the description of a graph here is that it's going to be a line. Okay, the next graph is the absolute value function. This is the equation f of x is equal to the absolute value of x. And so the x-intercept is at 0, 0. The y-intercept is at 0, 0. So the 0 is still going to be at x equals 0. The description of the graph, we say this is a V-shape graph. Notice it kind of forms a V. So you'll see problems that as anytime you see a graph that looks like a V, then you know it belongs to this family, and this is the parent of that function. The next one is called the quadratic function, and here you see the equation is f of x equals x squared. So your highest exponent would be a 2. So the x-intercept at x equals 0. The y-intercept is at y equals 0. And the 0 is the same as the x-intercept, so x equals 0. The description of the graph is when you graph these, you're going to get a U-shaped graph, and we call it a parabola. Okay, so this is more of a U-shape. The next one is called the cubic function, and these are for functions whose highest degree is going to be a 3. The highest exponent is a 3. And the x-intercept is at x equals 0. The y-intercept is still at y equals 0. So my 0 is x equals 0. And the description is goes up on the right side and down on the left side. So it almost looks like half of a parabola. And then if you turn it upside down, it's another half on the left side. And then the last one here is the square root function. And here you have the function f of x equals the square root of x. And so your x-intercept is at 0. Your y-intercept is at 0. The 0 is still 0. And you can see that the graph kind of like starts at 0 and shoots to the right. Okay, so starts at 0 and shoots to the right. So understanding these basic parent functions will help us to graph other functions in a little bit quicker method. And so let's look at the first examples here. Okay, so we have let f be a function and c a positive real number. And then it says the graph of y equals f of x plus c is the graph of y equals f of x shifted c units. And then we'll talk about how it's shifted. So I'm going to use my computer to show you what these graphs look like. So we'll graph the first one. So you can see that the first one is x squared. So let's go ahead and graph that. And so you're going to notice here this is a parabola. And it's the parent function because we have it at 0, 0. And so let's go ahead and graph that. So this is the parent function. Okay, and then the next two that we're going to graph are going to be x squared plus 2 and x squared minus 1. So I'm going to put those on the computer so that we can see what we're going to get. So the first one is x squared plus 2. And notice what happened to the graph. So the parent function, by adding that plus 2, it made the graph go up 2 units. Okay. So now let's do the other one, x squared minus 2. And notice what happens to the graph, the red graph. So the graph now got shifted down 2 units. Okay, so let's graph those on our paper. So the x squared plus 2 means that the points got shifted up 2 units. And the other one, for letter C, we can see that the graph went down 2 units. Okay, so this is letter C, this is letter B, and this is letter A. Okay, so by adding a plus 2, our parent function moved up 2 units. And by subtracting a 2, the graph shifted down 2 units. So it says, what is the difference between graph B and C when compared to the graph of the parent function? What do you think caused this difference? So if you compare B and C to A, then the graphs were shifted. And what caused that is adding a plus 2 or adding a minus 2. So we can say that the difference is that the graph shifted downward or upward when compared to the parent function. And adding a 2 or subtracting a 2 caused the difference. Okay, so if we go back to the definitions, we have the graph of y equals f of x plus c is a graph of y equals f of x shifted c units vertically upward. So the plus c means that your graph will move upward. If we're subtracting a number, then the graph is going to move downward. Okay, let's look at another example. Okay, so when doing these problems here, first it's important to identify the parent function. So we have the absolute value function. So you want to remember what that looks like. And so that looked like this picture here. So f of x equals square root of absolute value of x. So it's going to be a V shape. So the parent function, we can draw it first. So I'm going to draw a V shape here. Okay, so this is my f of x equals absolute value of x. Next, we want to graph g of x, which is absolute value of x minus 1. So notice that we're subtracting a negative 1. So that means that our graph will be shifted downward. So we can take some points from this graph and shift them down. So this point will come down 1, this point will come down 1, and this will come down 1. So my new graph will be this one here. Okay, so this is g of x is equal to absolute value of x minus 1. So now let's look at what happens if we add or subtract the number in the parentheses. So the previous example was outside of my x squared. Now we're going to look at what happens inside of the problem before it's squared. Okay, so we start with our parent function. We know what this looks like. So I'm going to go ahead and graph that one. So this is f of x equals x squared. And then I'm going to use the computer to help us see the graph. So let me erase these. So now we have x plus 2, and then we're going to square it. So notice what happens. So the graph got shifted to the left, right? So the parent function is here. By adding a 2, we move to the left 2 units. So let's look at this one, x minus 2. So notice here that the graph was shifted to the right. Okay, so if we graph these, by adding a plus 2, we're going to shift to the left. So I'm going to go 1, 2. And so my points would be here. So this is g of x. And for letter C, we're subtracting a negative 2. So we're going to shift to the right. So my graph will go here and here. So this is h of x, x minus 2 squared. So the difference here again is that the graphs were either shifted left or right. Okay, so graphs were shifted left or right when compared to the parent function. And what caused that was adding or subtracting, in this case by 2, inside the parentheses before the number was squared. It says use the graph of f of x equals square root of x to obtain the graph of g of x equals square root of x plus 1. And so first we want to identify the parent function, which is the square root of x. So the graph is going to look like this. So first we'll graph the f of x. And so that's the parent function, just looks like this. So this is f of x. And g of x, you can see here that you're adding a 1, and you're adding a 1 inside of the square root. So that's going to cause the graph to move to the left 1 unit. Okay. So if it was like this, notice that the 1 would be outside, then this one makes it move up or down. But in this case, it's inside, so we're going to move to the left. Okay, so this is going to make us move shift to the left. So we're right here. We're going to move over to the left one. So my graph would go something like this. So this is g of x. Okay, so let's try the next one. So first we'll identify the parent function. So you can see here that the parent function is the square root. So it's going to look like this. And then we want to see what's going on with g of x. So this minus 2 is on the outside. So this tells me that the graph will shift downward 2 units. And the minus 4 is going to tell me that the graph will be shifted to the right 4 units. So remember, you do the opposite. So negative, you will go right. If it was positive, you go left. Okay, so here my graph, I'm going to shift downward 2 units. So 1, 2. And then I'm going to shift to the right 4 units. So 1, 2, 3, 4. So my graph would go something like this. So this is g of x. Okay, so let's look at the next example. Use the graph of f of x equals x cubed to obtain the graph of g of x equals x plus 1 cubed plus 2. So first we need to identify the parent function. And so the parent function looks like this. Okay, so we'll plot that one first. So it looks something like this. And then let's see what happens here. So the plus 2 tells me I'm going to move, I'm going to shift upward 2 units. And the plus 1 means that we're going to shift to the left 1 unit. Okay, so we're going to go upward 2 units and to the left 1 unit. So my graph would go like this. Okay, so this red graph is my g of x, and my blue graph is f of x.